Hello and welcome back for another VMK in the game development series. In this VMK we're going to create the GUI button class, which we'll be using to create graphical user interface buttons inside of our game engine. We'll be using this button class to create toggle buttons, so if you click on these items, then they'll toggle from on to off or off to on. You can use these to be like a button that only highlights if you move over top of it to give you sort of extra information, things like that. We'll be using this GUI button class a number of different ways, but before we go in and actually implement the method for using them, which will be in the next VMK, this VMK is going to be focusing on the actual code that creates this button class. So let's go right into our Visual Studio project here. So let's go back into the GUI world where we have, under our object library, last VMK we created the GUI control.cpp and GUI control.h. This one, in this VMK, we're going to be creating the GUI button.h and GUI button.cpp. So under object lib, select add new item, type in GUI button, and repeat this for the .h as well. Our GUI button is defined at the very top, standard stuff. We need to include GUI control.h because you'll notice that our class called GUI button inherits from GUI control. We have a constructor where we pass in an ID number, a position, a size, an offset for the hotspot, and a hotspot size. We have a virtual destructor. We have a function called setOver and setPressed. And we also have a function called assignTexture. This is an important function which we use to designate which part of a TGA file is going to be used to represent this GUI control. We have a check to see if the mouse cursor is over top of the hotspot. We have stop pressing and render as well. Finally, inside of the member variables, we have an array which contains 4 coordinates for the texture coordinates of the bottom left-hand corner of the images that we're going to be using. The way that this is going to work is we can specify 4 different images for our GUI button. These 4 images will be used depending on which of those 4 states that our button is in. The texture we're going to be used is going to have an ID number, which is going to get saved here, and then the 4 individual texture coordinates that we need to know. We need to know the bottom left-hand corner and the top right-hand corner of this texture for each of these 4 states. So we're going to save those inside of this array over here. At the bottom we just have endif for the closing of the define, which is located up here. Okay, now let's go into the CPP file and take a look at the implementation. Our constructor, again, has all these parameters that we pass in, but notice that after the constructor definition, we have a colon, and then we call the GUI controls constructor with the parameter GUI underscore button. What this does is anytime we construct a GUI button, we know we're going to have to construct this GUI control, but we need to specify what kind of GUI control we are trying to construct. Because this is a GUI button, we're passing in GUI underscore button here, so that as we go into GUI control over here inside of the constructor, it's going to save the type as the GUI underscore button, which we passed in here, that is hard-coded. After the GUI control constructor is initialized, so after these guys are set to false, we then go in and set all these parameters for the GUI button. We set the texture ID number equal to 0 because we haven't assigned a texture just yet. The ID number gets saved inside of our member variable. Our position is saved as well as the hotspot offset. And for the size, we do a couple error checks. We make sure that the X value of the size is no less than 0, because if it is, this is invalid, so we just make it equal to 0. You can't have a negative size for a button. That we check the Y as well to make sure it's not less than 0. If it is, we just make it equal to 0. Same thing with the hotspot size. If the size in the X direction or the Y direction is less than 0, then we just make it equal to 0. And then otherwise, we're just saving the value that gets passed in. So that's our constructor. Destructor doesn't do anything, so it's blank. Our setOver function, what it does is it accepts a Boolean variable here. If it's true, it's going to save true inside of a member variable. If it's false, it's going to save false. For setPressed, same sort of deal. For checkHotspot, using the location of the mouse, we set the buttons pressed as well as over states accordingly. So the way we're going to use this is we're going to pass in our mouse coordinates and a Boolean flag here to represent whether the user is clicking on the button or not. Then, depending on these values that gets passed in here, we're going to set the appropriate member variables. So the first thing we do is we call isOverHotspot. This guy here is inside GUI control.cpp. You remember from the previous VMK. Here it is right here. It's checking to see if the mouse position is within the boundaries of the hotspot. So if this guy returns true, then we know we are over top of the hotspot, so we can automatically set the m_bover variable of GUI button equal to true. Also, we want to indicate that the cursor is over top of this specific control, so we're going to return the current ID number of this button out. You'll notice that checkHotspot has a return value, GUI_ID, and we're going to be returning our own ID out of our function here if we are over top of our control. If we are not over top of the control, then the return ID is going to be GUI_none, as defined up here, and our m_bover variable is going to be set to false. If we are over and the button is pressed, so this value here is true, then we can also toggle the button state by taking whatever value is right now and negating it and then saving it back to itself. So if it's false, we're going to negate it, make it true, and then save it back in, and then if it's true, we're going to make it false, and so on. And then finally, we just return the return ID number, which is calculated up above. The stop pressing button has no action that has to be handled inside the GUI button class, so we just leave it blank. And then we have our assigned texture. Now, assigning a texture is a little bit tricky because of the way that texture coordinates and pixel coordinates are defined. So the function's responsibility is to associate a texture with this button. If BAllSame is equal to true, then we assign the settings to all 4 button states. What this means is we have 4 different button states that we can work with. You can be not over the button and not pressing it. You could be over the button and pressing it. You could be over the button and not pressing it, and then we could also be pressed and not over the button. Those are the 4 states that we can be in. For each of those 4 states, we can have an individual image to represent graphically which state the button is in. The one thing we can do is, with the assign texture function, by calling this guy once, we can set one image to be the same for all 4 button states. You can use this just so that you can have a quick way to set all the values to be one texture. However, if you want them all to be different images, then you'll need to make sure that this last variable here, BAllSame, is not equal to true, so that you can then go and set individually which guy you want to set according to what texture coordinates and so on. And you'll see in more detail how this works in the next VMK, because in the next VMK I'm actually going to use this button class to show you how to get things rendering on the screen. In this VMK, I just want to go over what is inside this GUI class so you can see exactly what's going on behind the scenes. Okay, first thing we need to do is calculate the texture coordinates based on pixel values passed into this function. The pixel coordinates are values that range from 0 to the max size -1, with 0, 0 in the top left-hand corner. Notice it says here top left-hand corner, not bottom left-hand corner. Texture coordinates are values that range from 0 to 1, with 0, 0 in the bottom left-hand corner. Notice this is bottom left. So texture coordinates are bottom left, 0, 0. Pixel coordinates are top left, 0, 0. And you can see this inside Corel PaintShop Pro over here. If I have an image loaded up, the top left-hand corner here is 0, 0. If you look over here in the bottom section, it gives an output as to which coordinate I'm highlighting over top of. So if I move here in the top left-hand corner, right now I'm at 1, 1. And then as I move downward, I'm getting larger in the y. And then if I move across, I'm getting larger in the x. So 0, 0 is located over here. However, if you take a look at any of the code that we use for texture coordinates in ortho projected view, you'll notice that 0, 0 is located in the bottom left-hand corner. So we have to be able to convert from one coordinate space to another. And we take care of all that inside of here. One of the parameters that gets passed in here is UI max size. This guy is responsible for telling me exactly what is the full range of our image so that I know how to normalize it to be between 0 and 1. F size is the corrected value of the maximum size of the image, and we do that by subtracting 1. You'll notice that the size here is offset by a factor of 1 pixel, so we need to take care of that here by just subtracting 1 from the maximum size. If our size is less than or equal to 0, we know that there's something wrong because we have no image, or at least our image is too small to see, so we just return false. Otherwise, we'll continue on through and try to assign a texture. You need to specify a texture ID number to use whenever working with any GUI button. If this texture ID number is equal to 0, which is invalid, then we're just going to return false. Otherwise, we think we have a correct texture image, so we'll go and try to use it. The ID number that gets passed in gets saved into our member variable. Next thing we do is we check to see if our input values are correct. So we check to see if the left coordinate for our button's location, which is saved here under the X, is greater than the right section of the X. So if the left one is greater than the right one, which doesn't make sense, we'll return false. The left one should always be less than the right one because 0, 0 is located at the bottom left-hand corner. We also check to see if the coordinates in the y direction are correct as well. So the top one should be less than the bottom one because over here we can see that the top one is at 0 and the bottom one is going to be at some larger value than 0. So over here, whenever we pass in coordinates, the bottom y value, if it's less than the top y value, we know there's something wrong, so we return false. Now, next thing we also check is to see if the GUI texture value, which is this parameter right here that gets passed in, we check to make sure that this guy is actually valid. And I don't think I've defined GUI underscore texture just yet, so let's go and do that before I continue discussing what it is or how we use it. We'll add it into the GUI control.cpp, or actually no, GUI control.h. Let's just add it here underneath this guy. It's just a standard enumeration where we have 4 different states. We'll be expanding this a little bit later, but for now, just these 4 states will do. We have GUI text underscore not pressed, pressed, hover not pressed, and hover pressed. So those are the 4 different states that the button can be in. When you're assigning a texture, you need to specify which of those 4 states you want to be assigning the texture to. So you're going to pass in one of those 4 states into here, and what we're doing over here is we're checking to make sure that the value that you passed in is not greater than hover pressed, which is this guy here. And this guy is actually number 3. So if you're passing in a number that's larger than 3, it's going to break out and give you an error because this value is invalid. Alright, now that you have all these parameters checked, we can go in and make some calculations. We have 4 images that we can associate with every button. Each of these images will be saved inside of these array here. So we have a member variable which contains an array of 4 items, and each of them is a vector that contains 2 coordinates, and it's going to be a texture that is going to contain coordinates for either the bottom left or the top right hand coordinate. So when we're looking at the x coordinate of the top right or the bottom left, we can go and calculate them as follows. We can take the bottom left hand coordinate of the x and divide it by the maximum size. This will be a normalized value between 0 and 1 that contains the location of this texture. For the top right, we can take the top right-hand coordinate x and divide it by the size. For the bottom left and the top right y coordinates, we need to take into consideration the flipped y direction. We need to have the texture coordinates to be 0, 0 in the bottom left-hand corner rather than the top left-hand corner. So to take care of that, we take the size and subtract it from whatever is passed into here. This will effectively flip our image about a horizontal axis so that 0, 0 is in the bottom left-hand corner. So we take f size minus the bottom left y and divide it by the size, and then f size minus the top right's y and divide it by f size. So those will give us our texture coordinates that we need. One other thing is, if we pass in that our parameter here is not pressed, and we specify we want to use the same for all of them, then whatever we calculate up here, we're just going to copy that over onto the other 3 parameters that we have left over. So this guy will only save whichever guy is selected inside of the function call, but if you happen to select this guy as the guy you're trying to assign, and you've specified to use the same thing for all 4 button states, then you're going to take the value that gets calculated up here and save it inside of the other 3. So this is just a shortcut. You don't really need this, but I found that as I was working with so many different buttons, I didn't want to rewrite my code many times over. I tried to simplify it as much as possible, so that's why I added this little extra case down here. Finally, after doing all of that, we just return true, saying that we've assigned the texture correctly. When we go in and render our button to the screen, we're going to call render, which does the following. We take the texture state and we need to figure out which one we want to be rendering. So we have our be over and our be pressed as our member variables to use to figure out which state the button is in. And depending on the if statement here, we can decide whether we're hovering and we're pressed, we're hovering and we're not pressed, or we're not over top of it and we've either pressed it or not pressed it. So those are the 4 states that our button can be in. Using this texture state, we can then go and render the appropriate image over top of our button. So to do that, we need to make sure that we have a valid texture ID. If it's greater than 0, we assume it to be valid. We call GL matrix mode to be model view. We initialize it to be identity matrix because everything is with respect to the 0, 0 coordinate located at the bottom left-hand corner. We enable the texture and we specify the texture we want to use is this one right here. And we change our image to be using a white color, and then we begin rendering a quad. All objects that are in the GUI are represented as quads. If you want them to be a different shape, make sure you have your transparencies turned on for the image so that certain portions will be invisible and you can make them any shape and size you like. Now, when we go and render our object, we specify our texture coordinates. Our texture coordinates come from the bottom left and our top right hand values that we've saved earlier. So we can start off here. We take the bottom left x, we take the bottom left y, then the next guy over is the top right x and the bottom left y. So we're starting down here, we're moving across, then we're going to go up to here and then back across. Then we have top right x, we have top right y, and finally we have bottom left x and top right y. For each texture coordinate, we need to specify vertex coordinate, so we can get those from using the position value that we passed into our constructor. So here we start off at position x, position y, then we have position x plus the size in x, and then position y, and finally we have position x plus the size, and for the y coordinate we have position y plus the size, and then the last one is position x, and then the y value is position y plus the size in y. So after doing all that, we have now rendered our object. We just need to disable our texture and then we're done. So that's the way we handle our GUI button. Let's go in, compile our code, and it has succeeded, so that's good. So yeah, that's it for this video. Come back for the next one. We'll actually show you how to use this button class to get an object, well, a GUI button rendered on the screen, and then from there we can move on to the next GUI item.